This is going to be half of the material in section 12.1, which was about sequences and summation notation. We spent the first day of this section talking about sequences, and sequences are really easy. They're functions whose domain is the set of natural numbers. That means that we're only going to plug in to the equations numbers like 1, 2, 3, 4, 5, 10, 100, a million, a quadrillion. To find each successive term in the sequence is very simple. For example, in example A here, to find the first term of the sequence, you plug in 1 for n. So 1 over 1 plus 1 is 1/2. To find the second term, you do 2 over 2 plus 1, which is 2/3. To find the third term, you do 3 over 3 plus 1, which is 3/4. The fourth term is going to be 4/5. The fifth term is going to be 5/6. The 100th term is going to be 100 over 101. For the second definition, a sub n is equal to -1 to the nth power over 2 to the n. A sub 1 is going to be -1 to the first power over 2 to the first. Well, the way that powers of -1 work is if the exponent is an odd number, the answer is going to be negative. So -1 to the first power is -1. It's going to be -1/2. However, in the second term, when you do -1 to the second power over 2 squared, you're going to get positive 1/4. The third term will be -1 over 2 to the third. The next term will be positive 1 over 2 to the fourth. The fifth term will be -1 over 2 to the fifth. How do you find the 100th term? Well, remember I just said, if you raise -1 to an odd power, you'll get a negative. If you raise -1 to an even power, it'll be positive. So -1 to the 100th power is going to be 1 over 2 to the 100th power. I'm not even going to figure out what that is. We're just going to call it 2 raised to the 100th power. In the second example here, we want to find the nth term of a sequence whose first several terms are given. So let's look at A here. 1/2, 3/4, 5, 6, 7, 8, ... You can probably figure out what the next couple of terms are. They're going to be 9 over 10, 11 over 12, 13 over 14. Well, what I want you to do is I want you to first look at the numerators of those fractions. 1, 3, 5, 7. Those are all odd numbers. Now, when we talk about odd numbers, when we go to find the terms in a sequence, the first number we always plug in is 1. So the numerator can't just be n, because if the numerator were n, the first term would have a 1 in the numerator and the second term would have a 2. Odd numbers are always going to have this expression to explain them, 2n minus 1. Then I want you to notice the denominators, 2, 4, 6, 8. The next couple of denominators are going to be 10, 12, 14, 16. They're all even numbers. If, in a sequence, numbers go up evenly, we give them the expression 2n. So the expression that represents these terms is going to be 2n minus 1 over 2n. Let's look at the second part of the problem. I want to write an expression for this sequence, -2, 4, -8, 16, -32, ... I want you to notice that the term values are alternating in sign. Whenever you have an alternating sign, you're going to have a -1 to the nth power. Because remember, I said in the last problem, if you raise -1 to an even power, you get a positive. If you raise -1 to an odd power, you get a negative. Now I want you to go back and I want you to notice these numbers, 2, 4, 8, 16, 32. How do we get those numbers? Well, if you look at it for a second, these numbers are all powers of 2. 2 to the first is 2, 2 to the second is 4, 2 to the third is 8, 2 to the fourth is 16. So the expression that's going to represent this sequence is going to be -1 to the nth power times 2n. Now let's talk about a different type of sequence called a recursive sequence. A recursive sequence is going to be a sequence where the next answer depends on the previous answer. When you see this little expression a sub n minus 1, that's going to tell you to plug in the previous term. In order to do a recursive sequence, you need to know the starting value, or the previous term. So to find the first 5 terms, the first term we already know is 1. The second term is going to be 3 times the previous answer plus 2, which is going to be 9. The third term is going to be 3 times the previous answer plus 2, which is going to be 33. The fourth term is going to be 3 times the previous answer plus 2, which is going to be 105. The next term is going to be 3 times the previous answer plus 2, which is going to be 321. A special type of recursive sequence is something called the Fibonacci numbers. Fibonacci was an Italian mathematician who discovered that there was this pattern of numbers that seemed to occur everywhere in nature. And this pattern of numbers was hence called the Fibonacci numbers. And the Fibonacci numbers are not only so popular and so frequent in nature, that they devote an entire magazine to Fibonacci numbers in nature. We're going to talk about how this recursive definition works and find the first 11 terms of this sequence. So the first term in the Fibonacci numbers is 1. The second term is also 1. And to find the consecutive terms after that, you sum the previous 2 terms. So the third term, because we already know the first 2, is going to be the sum of the previous 2. The fourth term is going to be the sum of the previous 2. The fifth term is going to be the sum of the previous 2 answers. The sixth term is going to be 5 plus 3, which is 8. The seventh term is going to be 8 plus 5, which is 13. The eighth term is going to be 13 plus 8, which is 21. The ninth term is going to be 21 plus 13, which is 34. The 10th term is going to be 21 plus 34, which is 55. And the 11th term will be 55 plus 34, which is 89. And that's the first 11 terms of the Fibonacci numbers. Now let's talk about finding something called partial sums, because this is something that's important not only for calculus, but sections after section 12.1 will also include problems about partial sums. I want to find the first 4 partial sums and the nth partial sum of the sequence given by a sub n is equal to 1 over 2 to the n. Partial sums really means just adding up the terms in the sequence. So it might help if I know the first couple of terms in the sequence. So first of all, the first term is 1 over 2, and the second term is going to be 1 over 2 squared, and the third term is going to be 1 over 2 to the third, and 1 over 2 to the fourth. The partial sums do this. The first sum is the sum of the first term. The second sum is the sum of the first and second terms, which is 3/4. The third partial sum is the sum of the first 3 terms, which is 7/8. And the sum of the first 4 terms is going to be 15/16. So then the next question is, well, is there a definition for what's going on with these sums? Let's look at these sums. 1/2, 3/4, 7/8, 15/16. So I want you to notice that the denominators of these fractions, 2, 4, 8, 16, those are going up by powers of 2. We've run across that a couple times already. The denominator is 2 to the nth power. The numerators are always 1 less than the denominator, aren't they? So they're the denominator minus 1. So this is one way of writing the nth partial sum. Another way of writing it is to separate this into 2 fractions, in which case it would be 1 minus 1/2 to the n. But either formula works.